Good evening and welcome everybody. This is Obi-Wan Pez. We're in Simplex Pachinko. We are going to be doing some math tonight, and I dropped in a giving link for anybody who is interested in doing so. Tonight we are giving to Switchboard LGBT Plus, which is a UK charity, UK registered charity, which seeks to provide any sort of support line help to anything particularly related to sexuality, gender identity, sexual health, relationships, or just talk to people about how you feel. This is basically very much in line with the work that I was doing back in the United States, where I was teaching teaching the kids at my church about human sexuality, just as a very broad topic. Hey Laz, how's it going? So if anybody is at all interested, the link is there. You should be able to give to that if you're interested. I put in a goal for $200. I figured it's, you know, modest and also reasonable, so it's not like, you know, 1,000 or something like that. I don't think, quite honestly, I don't think we'd make it. Alright, and tonight, if anyone is at all interested in doing something in particular, then I would love to discuss what you all might be interested in. I have set aside our typical this one is Math Horizons, published by Mathematical Association of America, MAA, and we're going to look at a few of the puzzles that are in the open problem section. Oh, this one's a dozen questions about Pascal's triangle. So these are pretty well solved. Have the answers in the back somewhere, I'm sure. But being that my research has been fairly aligned with Pascal's triangle and trying to figure out stuff about it, we've done a few of these. So we wanted to just run a few of them and see how it shapes up. Content. Alrighty, so let's clear this stuff out. Oh, come on. Let's see. There are two ways to arrange parentheses around a sum of 3 terms so that one, a person, is only ever summing 2 terms at a time. So, for instance, with 3 terms, A plus B plus C, we have 2 different ways for this to work. It's going to be either A plus parentheses B plus C, or A plus B plus C. So in this case, our associativity rule is essentially what we're working with this. So number of terms. Guess with 2 we could probably fit 1, although it doesn't really say that anywhere. With 3 terms, again we had 2. With 4 terms, A plus B plus C plus D. Right, we could do this as A plus B plus C plus D. We could do this as A plus B plus C plus D. We could do it as A plus parentheses B plus C plus D. And we could do it as A plus B plus C plus D. And A plus parentheses B plus C plus D. I believe that those are the only 5 ways to do it. Hey, Famished. Reasonably well. We did some more Thargoid combat for 2 other streamers who were on today. One was Super Chicken, and and the other was just Mainer. Hey, both of these fine gentlemen were doing Elite Dangerous this morning, and yeah, we did some serious participation with both of them. Ended up absolutely destroying, like, I don't even know. It had to have been 1 billion credits. Probably. I'm gonna have to go back in after stream and check out the final tally for today. But yeah, it was like another 1 billion credits. So I've realized that now I actually have enough money in the account to purchase a fleet carrier, and I can just park all of my ships on the fleet carrier and jump the fleet carrier to different places and just go from there. So like I can create my little own home base somewhere, and then I've got like, oh, what you know, what particular that is a large spider. Why don't you hop into this bag? Thank you. Give me 1 sec. Yeah, so I can hop the fleet carrier into a completely into a particular area, and then say what kind of job do I need done, right? So then we discuss, well, if I need to do some exploration, then I'll take out that Mandalay, the giant exploration ship. If I need to do more combat-oriented stuff, then we take out one of our combat ships. And, like, as long as there's room in that particular star system, as long as there's room in that particular star system, we can set it up so that I just have my carrier. So, it's absolutely crazy. I can actually have a fleet carrier, and it costs something like think it was like 100 million credits a month. So that means that if I didn't have to purchase the ship itself, and if I didn't have to purchase fuel specifically, then I would basically have money for this thing for like 6 years. You know, give or take. Won a lawsuit against Epic Game. Ooh. Because kids were coerced to spend money in the games, I'm guessing, is the argument. Yeah, I haven't really gotten into any of the, should have asked for interest. I haven't really gotten into any of those, class action lawsuit type stuff. There were, you know, in a couple of cases, there were, like, when there was a data breach, right? Like, if they could say I was compromised in any way, then we could be compensated for anything that we had done. But, like, you know, I haven't had any actual problems apart from receiving a letter that's like, well, your information might have been stolen. Like, all right, cool, I'll change my password. Yeah. I don't really... Yeah, I've seen ads, especially for a couple of those playtesting platforms. I don't know how I feel about it, but... if it works for you, great. Mm-hmm. If we do A plus B plus C plus D plus E, okay. We're going to be taking pretty much everything that we've had up here and then determining where we can add E in all of those cases. So, like, we could take all of the previous ones. It's fine. Copy all that and paste it down here. Okay. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. Hey, Punching. Yeah, we're doing all right. Ooh. What the hell did I just do? Oh, no. That's the problem. Right, can't do that. Alright, good luck, Famished. Thanks for popping in. Hope things are going pretty well. Final season is Despair. Any particular, There was... Chat appearance. There we go. Ooh. That's not what I meant. Okay. Ah. Right, I decided not to do that on that account because I've got it on the other account, so I don't need to worry about that. Just practicing a bit before you take an exam. No time limit. Excellent. Just to make sure everybody has this in your back pocket, right? read every question before you really sit down for answering any one of them. So, like, once you get into the test, immediately read all of the questions, flip through all of the pages, and really try to let it absorb just for a couple seconds each. And then when you get to it, your brain's already going to be warmed up and, like, ready to solve it. In addition, your brain's working on it in the background. It's a background process, just like with a computer. If you can start working on these problems and warming up the appropriate regions of your brain before you get to it, you'll find that sometimes you'll just already know how to do something and be like, you know, when I first read this, I had no clue, and now I at least have some clue. Find the length of the curve of the cardioid. R equals 3 times the quantity 1 plus sine of theta. So my guess is that there is going to be some sort of nice, neat formula. I don't know it offhand, and I probably could look it up. However, I want to see if we can at least somewhat discuss it from, you know, the perspective of not technically knowing what it is immediately. Okay, so let's see. We start from theta equals 0. Why am I doing this? I have a create line button. Okay. Alright, so from theta equals 0, right? We end up with a value of 3. We end up with a value of 3 because the sine of 0 is 0. So 3 times 1. Okay, and then as we increase this, our sine value is going to increase up until we hit 90 degrees. So at 90 degrees, we end up with a value of 6. Right, and then at pi, so 180 degrees, we're back down to a value of 3 again. Gross. Alright, so... it's fine, nobody will know. Alright, now we create one that's double the size, give or take. Okay, that should be the center. Oh, look at that. Bam! At least one of them was right. Yeah, it's close enough. It's technically that's better. It's not exactly a circle, but it's close enough. Okay, so what we've got is something that starts from a measurement of 3. As we increase our value here, it's going to go out to 6. It's very curved. Yep, 100%. And in fact, right, R is going to already be increasing at 3. So it's more like that. Okay, and then similarly on the other side. Okay, then in the negative direction, we end up with at okay, increase our values. We're going to drop. It's going to become a negative. The sign is going to become negative, and then we've got still 3 times 1 plus whatever that sign is. At 270, the sine of 3 pi over 2, or 270 degrees, is going to be -1, which adds to the 1 that's there, which becomes 0. So cardioid, as you said, this is going to shrink down and go like that. And then on the other side, we're going to have something symmetric, like that. So we want to know, what is the length of the cardioid as we go all the way around the circle? So you could do it a number of different ways, number of starting places, ending places, whatever you feel like. If you just went from like pi over 2 to 3 pi over 2 and then doubled it, that's also another way to figure this out. So I'm pretty sure, right, we're going to be using a distance formula. This is going to be taking the integral from 0 to 2 pi, or taking twice the integral from 0 to... no. This one does not work because it is not symmetric that way. Twice from pi over 2 to 3 pi over 2. Right? It's symmetric about this particular axis between those particular angles. So that's the way that's going to work. This is a function of r dr or it's not entirely that. So let's delve into it, right? What is... right, we want to know... what we want to do is we want to take an individual small distance. Didn't send up your bounds correct? It's possible. Might as well look, right? Instead of just standing here and doing nothing. Okay. So I guess where did your setup come from? So the way that I would do this would be area formula derives half integral of theta 1 to theta 2 of r squared d theta. Okay.
This January, the energy price cap is due to rise. But with E.ON Next, you can start your year on the right track. Our Next Pledge tariff guarantees to keep your energy prices below the cap. So if the cap goes up or down, you're still winning. Beat the price cap and save with E.ON Next. Switching is a breeze. Visit eonnext.com today. Next Pledge is a 12-month fixed-term tariff adjusted quarterly to stay below Ofgem's price cap. Your bill depends
area.
on usage, T's and C's
Yes.
apply.
Okay. So that is the area formula. You don't want the area formula, right? You want the arc length formula. So an arc like this is going to be defined from theta 1 to theta 2. Right? We're going to consider that r is approximately equal for both of those things. So r1 is approximately equal to r2. right? When we get to infinitesimally small, it ends up working out that way. So the arc length of any one particular tiny thing is going to go from, right, how much is that? That's going to be arc is r theta. So again, in this case, R1 is equal to R2 approximately. So we just get R multiplied by delta theta is going to be our delta arc. Right? And then we do the usual thing that we do in Calc 1/2, which is we say, okay, we need to sum up all of the individual arcs I equals 1 to n of r sub I times delta theta sub I technically. And then we say, well, we're going to take the limit as n goes to infinity. Square root of r squared plus dr squared. I mean, like, it's not entirely awful. You're right. Right, so in theory, this is going to be the integral of theta naught to theta n. That's terrible. No, it's theta a to theta b. Of r times d theta. Right? In theory. Alright, let's just real quick check, because I don't trust myself entirely. Arc length formula, polar. Nope. You're good. Ah. Yeah, if you know most of the way to do stuff. Memorization. As much as I hate memorization, right? It makes complete sense. You'd want to at least know it the best you can. Aha. Okay, so, punching, yeah, you've got that. The issue is, in theory, yeah. You're paying $60, kind of need to learn it all. Yeah, also fair. Okay, So, yeah, this is an oversimplification that doesn't actually work. So, apologies. But that's good to know. This one, again, was our area formula. Okay. The thing that we're trying to do is we're trying to figure out, we could do the arc length, however, the other one that we could use is how it works in parametric equations, which is, again, go from A to B. We're trying to figure out, like, individually, right, these two sections here, we've got a starting point and an ending point. So, how do we get starting point and ending point? Well, we've been doing this ever since Algebra 1. Right, this is just our create a Pythagorean triangle for both of these, and then measure out the distance between them. So this is our distance is equal to not A. We're already using that. Right, distance in the x direction squared plus distance in the y direction squared is going to get us the distance squared. Right, so what we're really doing here is we're making this like miniature right triangle and then saying, oh yeah, we're just using the Pythagorean theorem on that tiny little right triangle. And we do that for every single individual position that we can get on the entire cardioid. Well, what are these, right? So delta x and delta y don't really mean anything unless we assign something useful to it. So we can say, okay, delta x can be the change in the x positions, right? So x2 minus x1, or in this case, if we're talking infinitesimals, right, this could be dx dt. It could also be dx d theta or dx dr. So, like, however we need it to work, any of those can all work. In our particular case, I think dx d theta is going to be the most useful. But we have to be careful because we're using two different types of variables. Let's just double check here. Yeah, okay. Yep, that works. Come on. Come on. Let's go. For some reason, Excalidraw and my stylus really dislike each other. Okay. So the way that we would, if we're going to go with like a whole explanation, you would never want to do this on like an exam. But if we want to talk about like, okay, how do polar coordinates work in the first place, then we're always looking at right, the trig stuff. Here's x, here's y, here's r. Here's theta. Right? Our initial trig stuff. Yeah. Right? So we go with the original trig stuff. We say here, the relationships that existed, the sine of theta was going to be y over r. Cosine of theta is going to be x over r. But If we're talking polar coordinates, then x and y are one thing, and r and theta are a different thing. So separate them that way. So y is equal to r sine theta, and x is equal to r cosine theta. Which, we also note that r in polar coordinates is a function of theta. And x similarly has r as a function of theta times cosine of theta. So what does that mean? Well, that means that if we want to take dy d theta, because that's our independent variable in this case, then the way in which x and y change is now going to be a product rule on two different functions of theta. So here dy d theta is going to be r prime sine of theta plus r times cosine of theta. Dx d theta is going to be r prime cosine theta minus r sine of theta. Okay there. Ish. Yeah. Ish. Okay, now that we get these two things, right, that was our dy d theta, dx d theta. That's what these are. That's our delta x and our delta y. So our distance, for our distance, we're able to use these two things and say that our distance squared is going to be equal to, and this is again like delta distance, you know, one tiny distance, is going to be able to be given by r prime cosine theta minus r sine theta, parentheses squared. Okay, plus r prime sine theta plus r cosine theta. Okay. And by rearranging stuff, yeah. By multiplying all of this out and rearranging it, it's ugly as hell, but nonetheless. Right, r prime squared cosine squared theta minus 2r prime cosine theta sine theta plus r squared sine squared theta. Okay, next, that's also squared. Next one is going to be plus r prime squared sine squared theta plus 2r prime sine theta cosine theta. And if you notice, right, by the commutative property, these are the same thing, so those are just going to add 0, so we can ignore it. Cool. And then plus r squared cosine squared theta. Now, if you also notice, right, we can factor these out, and we can factor these out, which leaves sine squared plus cosine squared, and cosine squared plus sine squared. Ah, isn't it great when stuff works out so nicely? So delta d squared is going to be equal to, here we have r prime squared times 1, because again, this is cosine squared plus sine squared, plus r squared times 1. Sine squared plus cosine squared. Well, that works out very nicely, doesn't it? So the individual one, our delta d parentheses squared, is going to be r prime squared plus r squared. And then, again, now we go up to what I'd said before. Now we say, okay, this is going to be delta d sub I. We're just summing all of these up as I goes from 1 to n, and then limiting as n goes to infinity. So now we need an integral of delta d yeah. Right, the total distance is going to be this. Right, which in this case, again, is going to be our integral from a to b. Again, just taking whatever limits of integration we have, times the square root of, and this was originally either dx dt or dx d theta, parentheses squared, plus dy d theta squared times d theta on the outside here. Excuse me. We've just done all of this work up here, which shows us that if we do have our dx d theta, dy d theta, then this all works down to just this part here, r prime, which is going to be our function up above, right? R is equal to a function of theta, for instance. So this is just going to be from a to b, square root of f prime, parentheses squared, plus f squared d theta. In this case, we said that f of theta was 3 times 1 plus, you actually said sine, but, you know, close enough. Hey, I bet you I'll get the same answer. Right, so in this particular case, the distance we said was going to go from 0 to 2 pi. Big square root. F prime of theta is going to be 3 times negative sine of theta. So this is going to be 9 sine squared of theta plus 9 1 plus cosine theta squared d theta. Right, so now our 9s get factored, take the square root, it's 3 on the outside. Here we get sine squared of theta plus, we're going to get the 1 plus cosine theta parentheses squared. We get cosine squared theta. We get a plus 1, and also we get a 2 cosine theta. d theta. Okay, it's going to be this. All this stuff is 1. All that stuff is 1 plus 1 is 2. You can factor a 2. That 2 comes out. You take the square root. So there you go for your 3 root 2. Yes. Okay, which leaves square root of 1 plus cosine theta. D theta. Yeah, it's a lot less convenient. Oh, clever. Okay. Waffle Roars, how's it going? Good evening, welcome back. Doing some Calc 2 at the moment. If you have any questions or anything interesting you want to talk about, let us know. Alright, so 3 root 2. Integral. And here, if we let u be equal to the thing we have... No, it's not going to be the thing we have. Right? Obviously. Because if it were just the thing we had, then we'd have the other thing. No queries today? Alrighty. 07 to you as well. We got out of... I was stringing my viewing this morning, hopping into a couple of Elite Dangerous streams to like just watch one after the next, and decided to do some flying with some of the commanders who were there. I don't even know how much in bounties we just made, but it's in the billions. So I believe my next purchase is going to be a fleet carrier to carry around all my ships. Yeah, it is a tidy sum. Right now Elite Dangerous is in an all-out war state, because the aliens, who have been kind of the constant antagonists since the original Elite Dangerous in 1984, they took a break in there, but you know, the enemies, or the aliens who have been kind of the constant threat, the constant antagonist, committed all-out war and invaded the Sol system. So we were like, oh, I see. So we kind of, we being like every commander that's out there, basically just rushed Sol and said, no, we're not doing that. So we can't technically rush Sol because the Titan ship that invaded is invulnerable until you like knock out its other offensive positions. So I put a call out on Monday probably, but I didn't need to say anything because, like, people rolled through the system that I was like, I want to take this by tonight. Yeah, they took that one in like 2 hours. And then they took 2 additional systems, like, very soon afterward. No, that was last Friday. Yeah, it was Friday morning. I was like, look, we need to coordinate, because otherwise we're not going to make it. Yeah, lol. I didn't need to say anything. They had it. Okay. So... Right. So we want... The way you had it set up was that you was going to be... Okay, so the way you had it set up is not going to really work for me. No offense. Because if we assume that this is u, then du has the square root in it, and so it'll cancel it out when you multiply. So we don't really want that. Yeah, just try something. It makes sense. Using the conjugate. Okay. You know what? F it. This is how we're going to do it. So... when all else fails, draw a picture, right? So what do we have? This is the sum of 2 things, which means that this is going to be the hypotenuse. So 1 plus cosine theta inside of the square root. Which means that this is going to be each of those individual things squared. So we'll do this one as 1, and this is the square root of cosine of theta. Because when we square it, we end up getting the cosine of theta. That's how that's going to work. Okay, we're better now. At least my brain's better now. Lol. This is going to be our angle, theta. I don't want to do that. No, that's going to be u. I'm sorry. That's not theta. That's u. Right, because don't mess with that. Okay. So what I want, what we have here, this is over 1, which means that this is a cotangent of u. And in order to get d theta, the easiest one we can work with is going to be... Sorry, that's not cotangent. Secant. Jeez. I'm okay, I promise. No. Cosecant. I taught trig for 15 years. I know what I'm doing. Alright, cosecant of u. And then in order to replace du, we then have to do some sort of trig thing. So my recommendation would be cotangent of u is going to be the square root of the cosine of theta over 1. It's not very pretty, but... So how are how are d theta and du related? If we take the derivative as is, if we take the derivative as is, this is going to be a negative cosecant squared u, right? Derivative of tangent is secant squared. So yes, derivative of cotangent is negative cosecant squared. Du is equal to, this is going to be a 1 over 2 square root cosine theta times the derivative, which is a negative sine of theta times d theta. Alright, make sure that I didn't do something else wrong, because goodness knows I've done plenty. Okay, so we could also attempt to do further investigations and try to see which one of these is going to turn out to be the best one. In my mind, they're all looking pretty gross at the moment, but could also be wrong. Let's try cosine of u. Is equal to square root of cosine theta over square root 1 plus cosine theta. Right, if negative sine of u du let's get serious, put it in the middle. Alright, parentheses prime. It's going to be 1 over square root of secant theta, 1 over cosine, plus 1. It's got fewer terms in it. Not to say it's necessarily any better. If we derive one that's already negative 1/2, it becomes negative 3/2. So negative 1/2 times 1 over that secant theta plus 1 parentheses to the 3/2 multiplied by the derivative of the inside. Secant is secant tangent. Certainly doesn't look any better. Okay. This one certainly doesn't make it easy, does it? Alright, this probably isn't going to make it any easier. At least not really. Let's do sine of u, which is 1 over square root 1 plus cosine theta. Okay, so here we've gone on adds, so, yeah. So we get cosine of u du is equal to Hey Phobos, I'll be back in a minute here, or 2, I guess. 2 minutes. Okay, if we take the derivative of the one on the right here, it's a negative 1/2, which comes down, and then this is going to be 1 plus cosine theta, which is 3/2. One more minute.
You made a mistake.
30 seconds.
Underestimating what you've taken on. I'm out of the cage 'cause you opened the door. You're as innocent as gold. 'Cause if you're falling for me, just be one. 'Cause I don't think you're ready for it. I'm not the one to mess around.
Okay. And we're back. So thank you so much, Phobos, for donating to Switchboard LGBT+. This is a UK registered charity which offers a helpline for anybody, particularly those who identify as LGBT+ in the UK, or LGBTQ+ in the United States, whatever it might be. But does offer, at the very least, like a safe phone line for people to call and ask questions, whether that just be to chat, talk about feelings and situations that are going on, or talking about human sexuality and trying to understand where one's place is in the world. I was teaching human sexuality as part of my church organization. We're Unitarian Universalist, and also lovingly called the Sex Church by a lot of other organizations, specifically teenagers, but you know. Yes, all the letters. However anyone identifies, that is how they identify. So, we seek to affirm the inherent worth and dignity of all persons. Those of you who have ever chatted in this chat know that that is something that is on my little tag. Maybe you've only seen it once and forgot about it, but it's down there. So if you ever click on chat rules, you can see it right there. So yeah, that is not my incredible wordsmithing. That belongs to the Unitarian Universalist Association. But I have been teaching human sexuality for, I think it was like 5 years or something like that. I guess some of the time during COVID didn't really count. But yeah, since about 2018, I think was when I actually went and got trained at it and decided to be part of the organization and help out. Or part of the educational side of things. So if anybody would like to, the link is there. Feel free. It's awesome, and thank you so much if you do. And if not, that's fine too. I was doing this just as like a the little. It was supposed to really be at the end of Thanksgiving. I just didn't get my shit together till this week. I was like, oh yeah, I had to do that. We'll probably do a few more over, you know, the coming weeks, just to donate to organizations. This one is a UK-based organization. I will also have a US-based organization at some point too. So, if you would like to specifically help your community, or, you know, somewhere, whatever, I don't know. If you would like to help something in your particular country, you can always look this stuff up and figure out the organization you would like to donate to yourself. So, so I figured out here that it might also be worthwhile to look at these sorts of things that we're going to create and see if there's any way that like stuff can drop out. So in this case, we're going to create a cosecant squared U that needs to like disappear somehow, essentially, in order to relate. That doesn't have to disappear. This stuff has to disappear. And so we've got on the other side cosecant squared of U, but it turns out to be this 1 plus cosine of theta. So that doesn't really help. So if we sift through a few of these other ones, right? So like sine of U is going to be 1 over square root 1 plus cosine theta. Which, if we look at this back over here, if we were to split it back up again, it could take care of something. But again, we're going to still have like all this other secant tangent stuff out there. Well, I mean, just as an exercise, right? Why not? Let's just look at that real quick. So this is going to be a negative 1/2. This is going to be the square. No. This is going to be the cosine to the third of theta over 1 plus cosine of theta parentheses to the third all square rooted. Or individually, I suppose. And realistically, again, I prefer these to be on the outside so that we can focus on other stuff. And the thing we have on the other side is a square root of 1 plus cosine theta. So that would get rid of 1/2, which would make it that thing squared and square rooted. So those bits would go away. Right? If we multiply that over from the other side, it's du is equal to -1/2 square root cosine theta parentheses cubed or whatever divided by 1 plus cosine theta with nothing attached there. Secant theta tangent theta d theta. This is going to take out 2 of these, right? It's going to be a secant is a 1 over cosine, which is 1 over square root cosine squared. So we can take out 2 of those, leaving 1 behind in exchange for getting rid of the secant there. It's something. It's not great, but you know. If we take the 1 plus cosine theta and multiply it to both sides, that is going to be a cosecant squared. Which, I mean, we're kind of moving around in circles maybe a little bit, but cosecant squared of u. We're going to multiply that over here. That takes care of this. Actually, wait. There's a better one. No. I was thinking try to get rid of both this and that, but that doesn't quite work. That could be a cotangent, though. It's a cotangent of u, not a cotangent of theta, so let's not get too over happy about it. Okay. So, yes, we can multiply by a cosecant squared of u to get rid of this one. We can also divide by the square root of the cosine. So that's going to be a tangent of u. Again, of u.
How did you do that? How did you do that?
So if we multiply by the tangent of u on both sides, that's the same as 1 over the square root of the cosine of theta. So that's why that's going to go away. Okay, and then here we have a tangent of theta, which we don't have anything nice to describe that. However, we could replace this with sine theta over cosine theta. Right, but if we need to trade out a sine for a cosine, we need a minus. Knew it was too easy, right? -2 times, move that over. Right, or we're not really moving it, but multiply on both sides. How can we relate tangent of theta to literally anything? Sorry, punching. I'm just like trying to play with this to see if we can do anything with it. At the moment, it's looking like, yeah, not so much. But I was trying to say, like, if we can just create some of these things, move them around a little bit, right? So, like, if we know that sine of u is equal to this thing here, then here we're doing the, like, breakout thing that we were talking about before. Or, sorry, we're reversing this. So instead of having 1 over the secant of this thing, we're going to have this bigger fraction instead, which then produces this fraction instead. And it kind of goes from there. But yeah, it doesn't seem to be working terribly well. We've got it narrowed down to just tangent of theta as like one of the offending terms. That's not going to work very well. We could knock the cosine over to the other side, cosine of theta, and get a cotangent squared that pops up. Cotangent squared of u that pops up over here. And that would knock out one of the tangents. But then we'd be left with a sine of theta. Like, we don't have anything to work with that. We don't have any useful terms, essentially. But that's one of the problems with asking somebody who like does algebra for a living. Let's see if we can derive things. Right, so trying to find d theta is really the problem that we're having here. So we can get 3 square root of 2 integral of cosecant of u, but now we need to trade d theta. And it's just not really working out too well. I'd say if you were to take your actual example that you had rather than the made-up one that I did, which is similar to but legally distinct from, show a bunch of work that gets to kind of like where we got to. You know, ask a couple of questions after that, and I think your teacher would probably be suitably happy. Office hours, woo! Just use a graphing calculator. Alright, no, I mean, you have one. It's called Desmos. You can hop onto... Did I close it? No, here it is. So, like, you can go... plus cosine theta r equals r. So I can do this. You're going from 0 to 2 pi. And then we say we want integral from 0 to 2 pi of r d theta. Right, so if that was it, then that'd be what we get here. We end up with just... Right, it's because it's not just that. Right, so if we were to set this up properly, so this is square root of r prime boo. You don't do that, do you? R is not a function. R prime is not a function. Really? I don't... Yeah, okay. Fraction dr d theta. Nope. Y equals.
We know, music interruptions aren't fun. But real quick, heard of Labara Mobile? Maybe? A Which recommended mobile network with a 4.8 star rating on Trustpilot. Oh, and also named the most popular mobile
Pirate
network
Souffle.
at the U
How's it
Switch
going?
Telecoms Awards
Good evening and
2024.
welcome. My name is Obi-Wan Pez, and this is N Simplex Pachinko, and we do mathy type stuff on Tuesday nights. So, just a dingy scientific calculator. Oh.
Labara, a smarter mobile network. There's only one thing better than enjoying all the sporting drama with your mates.
We do mathy stuff on Tuesday nights, and gamey stuff lately. It's been pretty much any other night of the week. Pyro. You got it.
In over 700 Green King sport pubs. No matter the sport, book your table now to secure the best seat in the house. Click or tap now to download the Green King Sport app.
We do basically anything from basic algebra all the way up through differential equations as something that I have taught over the last 15 years. I was a teacher in Maryland in the United States and am now currently living in the UK. So our family's moved a significant distance, and yeah, it's been interesting so far. It's been where are we? 8 months. So things are quite different. It's like R squared. We already knew that. But you don't understand R prime. Why don't we understand R prime? I was trying to do theta squared. That's trying to multiply. Right, it's not using R as a function. Right now it's using R as a function of theta, and that's fine. Because it's defined that way up above. You have fail math. I'm sorry. If there's any way that I can help you understand whatever it is you're trying to learn better, then let me know like what you're working on, where you are at, and I'll try to explain to the best of my ability like why certain things work. I'm not as much of a like tutor in terms of this is how things work and here's how to get you to just do it. There are several other math streamers that we have that style, and all of us teach math very differently from each other. Oh, Enigma. Our bot has apparently crashed. No. So, let's see. You're from Singapore? Alrighty. Must be morning over there, right? It's probably plus 8, plus 9. Yep. Yep. Well, that doesn't really work. Sorry, I was thinking there's another streamer from over that way, but I'm pretty sure his streams are all in Malay. So unless you actually speak Malaysian or Malay, then the more you sleep, your sleep paralysis will increase. Yeah. Yeah, sorry, I was thinking like I said, there's another streamer who's oftentimes over there, but again, if you don't speak Malay, it doesn't really work. But we do have a number of English language streamers who are all from either the United States, Canada, or now I'm in the UK. I'm not from. Your mother understands Malay. Well, if you're interested, his name is... Let me make sure I got that right. Uzair Itzaib. Yeah, there we go. Who apparently has like thousands of viewers. I don't know how this happened, but he is oftentimes doing mathematics and has like over 1,500 people concurrently in chat. I find it amazing. Somewhat hilarious. But he's also I think Valorant or maybe Fortnite streamer as well. Does some other stuff like that. So yeah, like I said, if you have any particular questions, let me know, and we'll try to help out any of your understanding. Let's see. Oh, I really wish the bot was working. We got... Actually, you know what? Let's see if I can do this poll from Discord. Actually, let me just give you the Discord invite, because that can work too. So anybody who is not already on the Discord, this is the Discord to Penn Center's Discord server, and he is a streamer and also a department chair for one of the colleges in British Columbia in Canada, and he used to come into my stream like all the time last year, and he and Zach would pop in and occasionally, you know, ask questions about how I taught things, and I was kind of like, oh, that's cool, you guys are like math teachers, and they're like, yeah, and they didn't say anything really about it. And then at some point I was like, wait, I just followed them back and they went live, and I'm like, wait, you guys are streamers too? And so I started hanging out on their channels, and we've developed this big community. It's really great. So there's what, 10, 12 of us who all, as much as we can, try and like share our knowledge and our audiences. 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 11 who are registered edu streamers on the server. So if you look in the left-hand menu, the second or third group down says edu streamers. So you can check out all of our things that are there. And Fobo Stream is also on that list, so you can go check her out too. I don't know if anybody else is here. If you are, shout yourself, or, you know, speak up. No, something. I don't know. So all 11 of us stream math or math-adjacent stuff like all the time. So, or I should say regularly. Oh yeah, no problem. I knew you were here. That's why I shouted you, or you know, here-ish. Despite your dad being an ex-aerospace engineer. So, like, I mean, the problem is that you have to work from scratch, right? Much Lurka bounce. Right? You have to start basically all over again. You don't get what your parents have or had. And them being there might make it slightly easier, but at the same time, like, your brain has to start from nil in order to understand the next few steps. Interestingly enough, there is a nice... I might have brought it upstairs. There is a fun fiction book which has a set of characters who pass on their knowledge genetically, so they can produce they can produce gametes which have their current memories, and so they get passed on to their offspring. It's really cool. That one is Adrian Tchaikovsky's Children of Time. So if you have ever, or if you've never heard of it, it's pretty cool. I would say that a lot of like the people who have learned their math a very, very long time ago probably have forgotten their primary school math, and worse, right? They know how to do something, they don't know how to teach it. So in order to figure out how to teach something, you've got to be able to break it down into its individual steps and then get somebody to be able to understand all of the individual steps and then be able to work that process by themselves. So it gets pretty tricky. It's hard. It's not easy, otherwise everyone would literally be able to be a teacher. But, you know, we typically require special certifications to make sure that, you know, you're a competent teacher. Turns out, teaching's hard. But yeah, like I said, if you are interested in letting me know what is kind of, what's one of your, let's just do one thing, right? What's one of your hang-ups? Let's try it. I'll try and see if I can give you a whole bunch of different ways. Maybe one of them you'll understand, and we'll go with it. So because I've been teaching for, you know, 15 years, I've accumulated a number of different ways of teaching things. And some work, some don't. Sometimes all of them work, sometimes none of them do. And then we've got to invent something on the fly. That's typically, that ends up being one of the most fun things. When I'm in the, like, especially lower, I hate to say lower, but one of the, like, easier level, either, you know, basic algebra or students who come up with, like, college algebra type stuff. This is the last class they ever need. They don't have to take math ever again. And they're like, I don't really understand this. And they'll show me something and be like, okay, well, judging by your work, here's where you went wrong, and like we'll talk about it, have a good conversation. All right, 1140. Okay, so you're past Calc 1. You've done your Calc 2. And you've done vector calculus?
Spotify Premium helps
Is that what I understand?
your music listening experience. Settle into your groove with endless tracks at your fingertips, all without hearing ads. Join now and get 3 months free. Cancel anytime. Tap the banner to learn more.
So, like, you've done... Actually, probably what we were just talking about over there, but... In this case, z is equal to, let's go with a 4 x squared plus y squared, something like that. So if we wanted to find the volume of the paraboloid that looks vaguely like this and has its equation here, then what we're doing in this particular case is trying to find slices of this paraboloid and find their volumes. They're going to be essentially little discs that are then going to expand outward as we move up. So in this case, right, the volume of any individual one is going to be x squared plus y squared is going to be a circle, right? So it's a circle this way. And it's right, as z increases, our x squared and y squared get bigger. That's our, okay, z over 4 is going to be the square of our radius, which is going to be x squared plus y squared. So, boy. The radius is going to increase awkwardly But if we want to find out what the volume is, right, we need R. Okay. So volume is going to be pi R squared times height, which is going to be delta Z. And then that can be sub I, and this can be sub I. The radius is actually going to be different every time. Delta Z we're going to fix as just being the same. So regardless of what height this is at, delta Z is just always going to be the same. So we don't really need an I there as a subscript, but who cares? It doesn't matter. Then what we're going to do is say we need to sum up all i's going from 1 to n of pi r sub I squared times delta Z, or delta Z sub I, and then limit as n goes to infinity. So then all this stuff ends up becoming an integral from a to b, z equals a to b. We get pi r sub I, r as a function of z squared dz. So we need a radius as a function of z. We already know what that is because that's going to be right here, right? R is going to be equal to the square root of z over 4, or R is going to be equal to square root of z over 2. And again, realistically, we're then squaring it again, so I don't know why I did that. Right, so R squared is going to be z over 4. So just literally replace that. Integral from a to b, pi times z over 4 times dz. So in this particular case, right, we're going to go from 0 to whatever our height is going to be. So we can call it ZF for like final. We could call it zeta. We can call it like all sorts of other stuff, whatever we feel like. Let's just leave it as B. So if we leave it as B as a variable, we can say, okay, whenever we want to end, we'll just end. We could also leave it as from 0 to Z and just deal with it. Okay, this is going to be pi over 4 times z dz. And so this becomes actually very easy. It's going to be pi over 4 times the integral of z dz is going to be 1/2 z squared evaluated from 0 to b. So pi over 8 times b squared minus 0. So our volume for this entire thing is just going to be pi over 8 times the height squared. So if we only let it be, 1 unit tall, then our volume is going to be pi over 8. If our height ends up being 3 units tall, then this is going to be 9/8 pi. So if you've ever done like 3-dimensional calculus, this is where this would start from. This actually ended up being a Calc 2 problem because I made it too easy. But if we had like an irregular surface, Alright, so imagine we have like a grid system. That's going to tell us like all of the individual shapes of this particular surface. Like it's a sheet, basically. Right, if we want to take some sort of like we want to know what the rate of change is of the height based on location, and like our height function is going to be a function of x and y. And, you know, we get some weird... I can't even make anything up that would be reasonable. But, like, x sine of xy squared minus cosine of x over y, or something ridiculous, right? We could play games with this all day, but if we have a height function that looks something like this, you know, this is, let's say it's out in the middle of the field somewhere rather than near zero, because that's going to cause problems. You know, we could find the rate of change in any particular direction by saying, all right, if we're going to do this, then we want to know what the partial derivatives of h are going to be in the x and in the y directions. So if we only move in the x direction, what's the rate of change going to look like? If we only move in the y direction, what's the rate of change going to look like as we only move in those orthogonal directions? So that is what vector calculus, or Calc 3 in some places, some other people call it Calc 4, but most of the time it's either vector calculus or multivariate calculus. So that's the kind of stuff we're dealing with. Then there's also like, what direction would something go in? If you had an object here, in which direction will this start to move? If you just put down like a golf ball, right? Take a little golf ball, put it on a little mini golf course, or a real golf course if you have one. But you put it somewhere, and then based on the shape of the terrain, which way will it move? So the way to do that is going to be something called a gradient. It's a terrible gradient. So the nabla operator, which is this upside down triangle, says that we're going to take the partial derivative of this thing with respect to x, and it will form part of a vector with the partial derivative with respect to y. So the answer for this is going to be a vector. And that makes sense because we're saying, okay, in which direction is this ball going to move if we set it down on the terrain and let it go? It's going to move that way, right? And how fast is it going to move that way? Well, if we want to know how fast and in what direction, that's a vector. So in those cases, partial derivatives will treat each other variable as constants. So in this particular case here, when we look at partial h with respect to x, only x is going to be a variable for that particular partial derivative. We say we only care about x. Every other variable is going to be treated as a constant. In this case, there's only y as the other variable. H is a function of both x and y, but x's and y's are the only things that are going to be our, independent variables. In this case, it is two independent variables, and they are independent of each other. So we need to say, okay, we're going to treat this just as x is going to be a variable unto itself here, and then y is also going to be a variable unto itself. Treat them separately. So my specialty is actually differential equations, and I have a playlist. So if you go to my page, and I should be uploading these to YouTube eventually as well. But if you look at my Twitch homepage, you should be able to find under playlists differential equations class. So I go through with two of our other streamer friends. It was Zach and Stuki. Zach, e to the 2i pi, and Ian Stuki were both placeholder students in that they were both experts already coming into the class, and their interest was more creating an interesting conversation than learning the material. I also exchanged for Zach as well. He had done a class in real analysis over the previous January to February, and I was a student for that class. Again, I'd already taken it, so it was kind of like, let's create some interesting conversations. And I also wanted to relearn it because goodness knows, I've forgotten so much. Okay, ads are about to roll, so I'm gonna go downstairs and grab another water, cycle through, and everybody else should probably get up and stretch and do something physical, and or grab yourself water, take care of yourself, etc., etc. And I will see you back in 3 minutes, so see you in a bit.
Light devotion, empty notion.
Welcome back, everybody. Hope you all had a good little break. Yeah, forgot to reclose the defeat. Why are we feeling defeated? Forgot to reclose the curtains. I had opened them earlier to let a spider out. Let's see. When we start looking at differential equations, oftentimes what we see is like there will be particular behaviors that are known, and so we look at the behaviors, build differential equations off of them. So we say like, well, we know that when, for instance, air is like moving forward in a weather front, right? It's just going to be essentially initial conditions. It's going to be like a solid wall, or it's large enough that over this space, it's going to essentially be a solid wall just moving forward of all air. Is it really going to work like that? No, not really. It's going to have little differences and little tiny things all over the place. Don't worry about it for now. When a front is moving in, it will act on a large scale as if it's like more of a flat, straight wall. So we just kind of pretend like that's going to be one situation. Then what we do is we say, okay, as it's moving forward, we know that the individual particles of air end up, let's say there was like terrain that came up in the way like this, just like a mountain. Right, and side, let's do top view as well. Essentially you've got like right, you've got this essentially solid wall of air that's moving toward it like this. And then when this air actually starts interacting with the mountain and with other particles of air around it, they're going to act in specific ways. So this one here, like it's going to try to either like go up and over, or it's going to kind of divert around the sides. Might have something that happens like this. Yeah, no worries. Right around here, we're going to see stuff like that. We're going to see stuff like that. And thank you for the follow. So, you know, the air that is coming at this mountain will either go up over the top or around the sides like that. And based on the different interactions with pressure and things like that, then we'll have different behaviors for all the individual particles of air. If anybody else does have any questions, let me know, and we'll try to get something answered. Pineapple is objectively one of the better fruits. Nobody gonna question me on that? All right.
We know, music interruptions aren't fun. But real quick, heard of Labara Mobile? Maybe? A Which-recommended mobile network with a 4.8 star rating on Trustpilot. Oh, and also named the most popular mobile network at the U-Switch Telecoms Awards 2024. Well, we just had to tell you that now you can join Labara from just £5 a month. Low cost, without the low quality. Join Labara from just £5 a month. Labara, the smarter mobile network.
Welcome to Group Therapy with Above and Beyond.
Hi, I'm Tony. I'm Bob.
Stuck back over here for a minute.
We're Above and Beyond. Subscribe to Group Therapy Radio on Spotify to get the best in dance music every Friday.
So if we add an E onto the end for all
There's
these,
only one thing better than enjoying all the sporting drama with your mates, and that's scoring 20% off your drinks at Green King Sport Pub. Just download the Green King Sport app to enjoy 20%
right, we start
off
with
drinks
5
available
different
for
things, and this is just adding an E on the end. Then we say, or rather, this is equivalent to just putting parentheses around all of them
Tap now to download the Green King Sport app.
and leaving E on the end.
drinkaware.co.uk for the facts.
And then for each of them, we could shift the parentheses as they are to include E and D, or E and whatever the first group is of numbers. So in this case, we could have put all of that in parentheses, excluding the A. Over here, we could have done here. Here, we could have done those. And here, we could have done those. And then within C plus D plus E, that could have also been switched to C plus D plus E. Alright, those two already accounted for that. And then within this one, that is itself I guess technically with both of these together. Okay. With each of these, this then becomes a, like, grouped set of however many things we have. So all of the ones where we change around all the things on A, B, C, and D and leave E by itself are already accounted for. So by including parentheses around E, this turns this into a nested 3 object. So there are going to be 2 ways to do it. Right, so this adds 2 to this one. Shouldn't do that. Alright, adds 2 to this one. That adds 2, just literally the ones we see. There's no difference, really. Ah, wait, no. There are 4. Because either... Okay. It's either the one we see, or there are 2 more. Hang on. C plus D plus E, or C plus D plus E. So there are 2. And then the one we see where the first stuff is grouped, and... Okay, so that's 3 total things. For these, we either have what we see now, or grouped on D plus E. So that's going to be plus 4 total. And again, these are going to be either. So that's another 4 there. Then we have to take into account the possibility that it? So in doing this one, we said that we took these, we said, okay, this is either, these 4 things are either 3 plus 1, or 1 plus 3, or 2 plus 2. It's the number of partitions. So we had 4 things. How many ways can we partition 4? Where order matters. Right? So 1 plus 2 or 2 plus 1 are all going to give us 3. This is going to give us 4. So do we do 2 plus 2, or do we do 2 plus 1 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2, 1 plus 2 plus 1. Okay, so like the number that we're going for, n, is equal to those things. And then the number of partitions we have are going to be those. So for 5, we want to know all the possible combinations of 2 plus 2 plus 1, 2 plus 1 plus 2. Oh, right. 2 plus parentheses 2 plus 1. 2 plus 1 plus 2. And 2 plus parentheses 1 plus 2. And then we get 1 plus 2 plus 2. 1 plus 2 plus 2. Okay. Those are all 4s. Why am I doing them in this row? Nah, it gets us 5. Okay, cool. Not ready to get that. Alright, we have to be in 2s wherever possible. Seems to be a little bit weird way to say it, but it's essentially what we're doing here. So alright, because now we can also do all of these with 2s on the outside broken up. Wait. Yeah. So those are like 3 operations, or 2 operations. But what if we break it up into 3 operations? Because this one here could also be 1 plus 2 plus 1 plus 1.
I'm on my own, broken alone. I feel the rain crashing down all around this empty town.
Right, but then we need to... Then we need to specify which one comes first, which one comes second. So this could be 1 plus parentheses 2 plus 1 plus 1. Yeah. And then plus parentheses parentheses 1 plus 2 plus 1 plus 1 plus 2 plus 1. No ones can be grouped together in the way that we have it right now. All right. I think we are probably going to wrap things up. If anybody does have any other questions about mathematics, other cool stuff, let me know real quick, and we might be able to get something in. But otherwise, we're getting pretty close to end time, and reaching the end of my useful period of consciousness. Alright, so let's see. Thank you to anybody who donated to Switchboard LGBT Plus, which is the UK registered charity that has a support line for anybody who wants to talk about human sexuality and trying to understand any sort of issues that might come up, or where they fit in the world and how awesome people are. So we will be keeping that running. As far as I know, it should be possible, and we should be able to have that on. If you would like to donate instead to a U.S. organization or wherever you are in the world, please look up registered charities in your particular area and make sure that they are vetted, so that, you know, they, well, first of all, registered charity, right? So that you know where that money's going. You may wish to do a bit of research in order to figure out whether a particular organization aligns with your particular goals. Switchboard mostly is looking for making a support line to discuss anything related to sexuality, gender identity, be it sexual health, relationships, or just how you're feeling. It is a place to explore, talk, and truly be heard. You talk, we listen. They operate in the UK 10 a.m. to 10 p.m. every day, 365 days out of the year. And there are other lines in your local area which will help out with all of this. So if you do have any particular issues, you think you might be experiencing some sort of mental health crisis, or you just want to talk with somebody about what's going on, again, just make sure that you have vetted a particular organization and they are supportive and helpful. Alrighty. We're going to head on over to, I think, actual education.
Our next pledge tariff guarantees to keep your energy prices below the cap. So if the cap goes up or down,
we also have a couple other people. Let's see. Mathematicas Professor here. HC is a Spanish channel.
Your bill depends on usage. T's and C's apply.
Problemas y más problemas. Problems and more problems. Right, Dr. Gold is on. I think we're probably going to go see Dr. Gold tonight. Yeah, I had misread Professor Hiera, and I thought it said problemas y mis problemas, or whatever the appropriate possessive pronoun is. I don't know because I don't speak Spanish. Alright, so we're going to head on over to Dr. Gold, and he typically does SAT type help. So if you have any particular questions on that, let him know. Let anybody else know who is working there tonight, and we'll see how things go. So have fun, everybody. See you next time. We'll be back for gamey type streams on Friday, certainly, and then I'm going to be taking the next week off because our family's going to head to Germany and have some fun in Europe. So have a good night, everybody. My name is Obi-Wan Pez. This is N Simplex Pachinko. See you later.